Assalamualaikum dan selamat pagi. Selamat sejahtera. Apa khabar? Kita selalu tak berjumpa lah ya. Walaupun kita berdekatan tapi sentiasa berjauhan. Right. As you can see on the screen here, this is actually our jadual kalender akademik kita, dan masa berlalu begitu pantas. Time flies, and I always fly, leaving you. So you are very unfortunate to have me to teach the course, yeah, because I'm not always around. That's very unfortunate, and I feel guilty for that. So how do I going to make up for this? Well, I know some of the lectures, some of the topics for starch and even for fats and oil, we don't have time to cover in a face-to-face lecture. This is the best to have a face-to-face, yeah. But now because of the situation and the constraint, I have to put some of the lectures online, and we don't have time to really go through it. Yeah? Now it will be on fat and oil. So what we are discussing now is on the fat modification. Yeah, on fat modification. So when we talk about fat modification, basically we refer to mainly three, yeah, which is hydrogenation, interester purification, fractionation. But some people, some books, or some industries also refer to blending different types of oil also as another type of modification. Yeah. In fact, blending is a very popular practice in the industry. Blending different types of oil, having different types of composition, different degree of unsaturation, different iodine value. So they blend different two or more different types of fat or oil to get a different solid fat profile. Okay, solid fat profile. And this is one way also to eliminate trans fat in the fat. Okay, so hydrogenation, as I mentioned in the previous lecture, has been one of the most popular type of modification, because the process has been established very long time. Technically, it's quite simple, very easy to control. We can change the various reaction parameters during the hydrogenation process. The physical factors here, the temperature, the hydrogen, which is the we need for the hydrogenation. We can control the speed of agitation. We can control the concentration of the catalyst. Okay, so by controlling this process condition, we can control the hydrogenation to be more selective or the less or non-selective, so-called selective or non-selective hydrogenation. Please refer to the notes, because I don't have time to go details to explain, and some reference to understand more about the meaning of selective and non-selective. But we can control these process parameters so that we get whether very high selective or very low non-selective process in order to. So by controlling these parameters to make the hydrogenation more selective or non-selective, the effect is we can get different degree of solid fat content. By doing hydrogenation, basically, we are increasing the amount of saturated fat, saturated fatty acid. Yeah, by the whole purpose of hydrogenation is actually to increase the degree of saturation. By increasing the degree of saturation, we increase the solid fat content. Very simple. Hydrogenation, we add the hydrogen to the double bond. So the double bond will become saturated bond. Unsaturated becomes saturated. So we increase the degree of saturation. Palm oil, for example, contains around 50% unsaturated fatty acid and 50% saturated fatty acid, about 50-50. So when we do the hydrogenation on palm oil, we will increase the degree of saturation above 50%. So maybe now we get 60, 70, 80% saturation. And by doing that, the result is, the effect is increase of solid fat content. So this is good to make solid fat, plastic fat, such as margarine. Yeah, such as margarine. But again, I repeat, the problem with hydrogenation is the byproduct, which is the trans acid, the trans fatty acid, which has been shown. Many research have shown that it can cause increased risk of coronary heart disease and so on. So now, the industry around the world which use fat try to use trans fat free from trans fatty acid as low as possible. And therefore, now we have problem with hydrogenation, because hydrogenation always will produce trans fatty acid, especially for partial hydrogenation. Okay. So partial hydrogenation, when we do hydrogenation, basically we change the amount of degree of saturation, and therefore we change the degree of solid fat content, and therefore we change the so-called SFC curve. SFC stands for solid fat content, or sometimes we use the term SFI, solid fat index. The difference between SFC and SFI is the way we measure the solid fat. But both SFC, SFI give us the measure of the amount of solid fat in the product. So we get a profile, because we can plot at different temperature, the fat will contain different amount of solid fat. At any temperature, technically, the product would contain some amount of solid fat. So we can plot a graph, and this graph is called SFC profile. So by changing the degree of hydrogenation, we can change the SFC profile. Okay. And also we can get a different type of crystal to form during crystallization. So selective hydrogenation, we can get a very steep curve, whereas non-selective, we can get a very maybe more flat curve. Okay. I'll try to maybe make one online lecture also on this, so that maybe things that are not clear to you, I'll try to explain that. Anyway, by partially hydrogenating a liquid oil, so we start with liquid oil, yeah, which contain high amount of unsaturated fatty acid, high melting point fat. A very specific melting profile and the right mouthfeel can be achieved. Yeah, partial hydrogenation. So we can control the temperature, we can control the pressure, we can control the the agitation, we can control the amount of hydrogen, so that we can get a specific melting, a specific curve, the SFC curve. So very versatile process. But the content of trans fatty acid often increase to 15 to 25% under certain circumstances. And under certain circumstances, the content may be as high as 50%. No GRU. Yeah? So, by definition, the trans fat-free product would contain very, very low amount of fatty acid, around 1 to 2%. Yeah? So, no good. So, we have to do something. So, the alternative would be by doing full hydrogenation. If we still want to use hydrogenation and yet get very low amount of trans fatty acid, so we can do full hydrogenation, because by fully hydrogenating the fat, all the double bond will be eliminated. Eliminated means it becomes saturated now. Yeah. But then, okay, now the trans fatty acid content is low and we do full hydrogenation. But the problem is the melting profile. We cannot control we cannot get a certain specific type of SFC curve. Yeah, because we get full hydrogenation, full saturation. So it's not very flexible to get a customized profile, customized solid fat content profile. So that's an advantage. Advantage is low trans fatty acid. Disadvantage, not very flexible to get a certain profile. Fats containing high proportion of high melting triglycerides can leave a waxy mouthfeel in the mouth. For example, hydrogenated palm kernel oil. Degree of hydrogenation is important to give. Therefore, degree of hydrogenation is important to give desired melting property. If the fat contains a lot of or high amount of high melting, meaning the triglycerides have a high melting point. So this can give the so-called waxy mouthfeel, greasy type of mouthfeel in the mouth when the fat melt. So that's probably not the kind of mouthfeel that we want. Yeah. For example, in the chocolate that use hydrogenated fat, Malaysian chocolate, especially not the premium chocolate, kan? Yeah, those like Cadbury, you can see on the label hydrogenated palm kernel oil, kan? Compare kalau you makan the Hershey chocolate, kan? You can feel the greasy, macam greasy type of mouthfeel. So those the disadvantage of that. So okay. So what are the different approaches, other strategies to get a trans-free? Yeah. So one way, if we still want to do the hydrogenation, one way to achieve a more suitable melting profile without the trans fatty acid is to first mix the fully hydrogenated fat with a naturally liquid oil. So the liquid oil, of course, is almost trans-free. So now we have a full hydrogenated fat, which is also almost trans-free. So now by mixing them, blending lah, this is a blending, at a certain proportion. So we can play around with the ratio. How much is the full hydrogenated fat? How much is the full liquid fat? Mix them in certain proportion. So that is one way. That is one way. Yeah, and we can also so the variable here, or what we can play with, is actually the ratio. Yeah, how much? If you want to get a certain solid fat content, you want to get a certain solid fat content in the final fat. So you just blend certain amount of full hydrogenated fat with full liquid fat. And another approach which is more expensive, this one probably cheaper and actually widely used. But another method or another approach is by using interesterification, which used to be an expensive process, but now getting maybe more costly, effective, more and cheaper, yeah. Compared to hydrogenation. Hydrogenation is still considered, the easiest, the cheapest, the most flexible method. But now we have to move. We have to find alternative. So therefore, we have to look at either by using blending or by using interesterification. What is interesterification? You can see later. So interestify the mix to get the specific mouthfeel of the end product. If by doing the mixing here, still doesn't fill our requirement in terms of the solid fat content and in terms of the mouthfeel that we want to get, then we can subject the mixture here, or the blended fat here, to a process called interesterification. Okay, so we can do further modification on the blended oil here, on the blended fat here. So what is interesterification? So now we know a little bit about hydrogenation, which is a simple process, adding the hydrogen to the double bond to make it saturated. Next, we have interesterification. Okay, fat basically are esters, right? Triglycerides, they are esters, and they are mixtures of esters, mixtures of triglyceride. Okay, so now, before that, additional reading. I think I've given this the link in Edmodo, right? The full article, and okay, very good. Very good article, very comprehensive. Please read, please. Yeah, 2004. But if you can find a later one, please also refer and share. Okay, now we talk about interesterification, i.e. The short form. Sometimes in the industry people just use the short form, so please also know the short form, yeah? i.e. No, Internet Explorer refers to reaction between different triglycerides. Reaction between different triglycerides. Imagine the oil, we have hundreds of TGs, triglycerides, and they can actually interact with each other. With the keyword here is rearrangement. Interesterification is about the keyword rearrangement. Rearrangement of what? The fatty acid in the TG, in the triglycerides. Rearrangement of the acyl group or the fatty acid group within and between. Within and between. Okay. If you want to make an analogy, perumpamaan, contoh analogy, if I have two hands, anyone with more than two hands? Okay, Shen ada two hands. Okay, I want to exchange my left hand with the Shen's right hand. Okay, so we exchange. So this is a fatty acid. This one fatty acid, one fatty acid. Shen have another two different types of fatty acid. So I can exchange my left hand with Shen's left hand or Shen's right hand. So that is, so I'm one molecule of triglyceride, Shen is another molecule of triglyceride. So we can change hands. Right? So that is between molecules. But I can also, can I change hands within myself? I want to change my left to right hand. Somehow lah, ini crazy example. Yeah? So it can be within the molecule or between the molecules. But by exchanging hand, if we exchange hand for some crazy reason, okay, how many of us here, let's say we have 30 people here. So we have multiply by 2, we have 60 hands. Yeah? So let's do the exchange. Finally, different person will have different hands now, but the number of hands still the same, right? Still 60. So in interacidification, there's an exchange of fatty acid within and between the molecules, but the number and the type still the same. So that's what interacidification. But by doing the exchanging of the fatty acid, changing the position of the fatty acid within and in between the molecule, the effect would be a drastic effect on the physical properties. So when we say physical properties of fat, we always refer to the melting point. We always refer to the solid fat content. Okay? So there will be a drastic effect on the physical properties of fat, but no change in fatty acid composition and degree of saturation, because unlike this is where the interacidification and hydrogenation different. Unlike hydrogenation, degree of saturation berubah. But in interacidification, the degree of saturation tidak berubah, because we just exchanging the position. If you recall the previous exam, the previous test, kan, you get question like compare and contrast, right? So I'm telling you the sort of, what I expect of how we should learn this subject lah, Not really you understand about hydrogenation, interacidification, but you should know what are their differences. How do they differ from each other? How do they and how these differences impact on the quality, on the physical properties of the fat or the product. Yeah? Things like that. You should go to the higher level rather than just memorize what is this, what is that. So this process can be applied directly to naturally derived oil and fat, or to hydrogenated, or to fractionated. So interacidification can be done on the native oil, original oil or fat, or we have done the hydrogenation, full hydrogenation just now, and after that we do the interacidification, or we blend the full hydrogenated fat with liquid, full liquid oil, and then after that we subject that to interacidification. Or banyak sangat ornya, we do the fractionation. We are going to look at fractionation next. Then we get one fraction. We can get many fraction because remember oil contain hundreds of triglycerides, different melting point. So we can get one fraction with melting point from, say, certain temperature to certain temperature. Another fraction. Now we can take one fraction and do interacidification, or we can mix one fraction with another fraction, and after that blend them, mix them, and we do interacidification. So what we want to achieve at the end of the day, why we do all these things, we want to get a specific solid fat content profile, because the solid fat content would define the physical properties of the fat. That's all. These are modifications, just like we modify starch to get a certain desired properties. So the objective of interacidification is to change the overall melting profile, overall melting profile, usually to smooth the SFC curve. You will see what's the meaning of to smooth the SFC curve, or the to change overall melting profile or the melting profile of the mixture. Okay? Melting profile of one single fat or the mixture of fat. Usually a decrease, meaning a decrease in the melting point. Yeah? What's the meaning of this? So let's say in the oil or in the fat, we have two different triglycerides. R1, R2 represent the triglycerides. So we blend the oil. We need to use a catalyst to catalyze the reaction. Then we get the interesterified oil. In this case, it's a randomized interesterification. Random interesterification meaning the exchanging of the fatty acid in the fat between the triglyceride can happen randomly. There's another type which is directed, which is more, controlled. So we can get now we start with this one, two homogeneous triglycerides, but we can end up like this. Yeah. We start with two species, we end up with more. We start the R1, this triglyceride with this type of profile. This is what we meant by SFC profile. We plot the solid fat content at different temperatures. So we get this curve. So oil 2, this one oil 2, this one oil 1. It's like that. When we interesterify the oil, these two now come like this. So we can see there is a drastic change in the solid fat profile. So usually we define what we want. Do you want this type of profile, or it can be different shape, can be different, So if I want like this, so now we have to decide which oil that when I blend them in a certain proportion and interesterify them under certain condition would give me this. So of course, this is not an easy things to, it's not a simple thing actually. So we need to do a lot of experiment and so on. Today, Shen.
There are so many kinds of oil there, so will there be a lot of curves?
Yeah.
The curve shows only one of them.
No, when we mix, we start, in this case, this is a simplified example. We start with two different type of oil. And now we imagine, this again very simplified case. Yeah? We imagine that in the oil there's only one type of triglycerides. Yeah? Very homogeneous lah. But in the real world, it's not. Each oil contains, hundreds of triglyceride, different degree of saturation and unsaturation. But in this simple case, we can see each one, oil 1 will start with one SFC. Oil 2 with its own SFC profile. When we mix them, we measure the SFC, it will give us this one. If that is what we want, fine. If that is not exactly we want, then we have to figure out, okay, now maybe I'll change this to another type of oil. Or maybe I add a third oil. So as you can see, there are many possibilities, and it's not that easy. How to make life easy? How to make our experiment or our trial and error to make it easier and faster? Okay. So nowadays, we can use a software. Yeah. For each oil, palm oil, canola oil, olive oil, whatever oil, we know the exact composition of the fatty acid from, of course, from the analysis lah, yeah, using GC or whatever the modern method. We know exactly the type of fatty acid, the degree of saturation of the fatty acid, the ratio of the saturation and the ratio of the saturated and unsaturated fatty acid. We know. Okay. Now, by using the and we know also the solid fat content SFC profile. So we have all this information. Remember, information is power. So we have this data for each oil. We use the software. Okay. Now we tell the software, I want this type of profile. Please tell me which two oil, when I blend them, I would get this. Wow. Powerful, eh? So the software will, and oh, you can blend canola oil with palm oil in this proportion. Yeah, can do that. But, okay, you tell the software, don't tell me any random two oil. I want to use palm oil and maybe, let's say, I don't want to use corn oil. Corn oil is LCS, kan? So I want to use, say, canola oil lah. Eh? I just want to use palm oil and canola oil. And I want this curve, this kind of SFC profile. Please tell me what proportion I need to mix them. And if I do the interestification, whether I would get this or not. So to make life easier nowadays, the industry can use the software. Otherwise, it's going to be, of course, they can do experiment, but to really closely match the profile that we want is not that easy if we just do simple trial and error. Okay. Now, this example is actually random inter-explication, meaning that we can exchange the fatty acid. But the industrial process of inter-explication can also have the process in a more directed, meaning that we can specify more specifically the kind of composition of the final triglycerides that would give us a certain profile of the final product. Yeah. And we can also do the interesterification by chemical interestification or by using enzymatic interesterification. This one I don't want to elaborate too much, but you just know that can be done by using enzyme. Enzyme, as usual, compared to if you use acid or alkali, enzyme always more. Yeah, okay. Enzyme is always more specific. We can control more. The product would be more predictable. Yeah, but the problem many years ago, using enzyme is always more expensive than using chemical method. But now, of course, when the industry can produce enzyme in a more cost-effective way, the process will become cheaper and cheaper. Okay. Okay. Let me give this is a real example of how we can use interesterification to produce the specific type of fat with a specific type of solid fat content. So in this case, we have a solid fat containing about 60% of essential fatty acids. essential fatty acid, yeah? The fatty acid that is essential for our body, essential for the physiological process in the body. Solid fat containing about 60% essential fatty acid can be obtained by directed IE of, in this case, sunflower, and blending it with 5% hard fat. What is the meaning of hard fat? Sometimes we call it hard stock, yeah, fits for the meaning that we have this basically the so-called the plastic fat that has been fully what? Hydrogenated. Okay, so this again example, one good example of blending. Yeah, blending. Then after that, interesterification. Okay. This long sentence is just to say that by doing interesterification we can improve the quality of the fat. Yeah. Another example. Okay. Nothing much to explain, just example. Because now I want to jump to fractionation, another type of modification. Okay. In Malaysia, if we go to most refining factory that do the refining, we always have the process of fractionation also carried out in the same factory. Someone went for the training, forgot now already, went for training in the palm oil refinery. Mongling. Mongling. Oh, you didn't go to the. Oh, okay. Why nowadays not many students go for training in the palm oil? We have so many industries. Yeah. Banyak ada kita punya kilang palm oil refinery. You can learn a lot if you go there. There's so many unit operation you can learn also. You learn about unit operation kan, evaporation, crystallization, filtration, macam-macam. Yeah. Anyway, fractionation is a very simple. The principle of fractionation is very simple. It's a physical process as well. That's why you learn in IMK 209 about the process of crystallization. So this is one good example of where we can apply crystallization. Basically, remember, so you have to recall back your IMK 209. The process of crystallization can be done starting from two types of we can start from a solution, or we can start from a melt, MELT. So the liquid oil is a melt. A liquid oil is not a solution. We must use the term correctly. When we say solution, must have solute and solvent. Yeah. So when you dissolve sugar in water, you have sugar solution. So to get crystallization, you have to go to supersaturated state. Then go to the labile state, you can get spontaneous crystallization. If you are in a metastable state, you can add acid to get the crystallization, right? So remember that. But in fractionation, we start from a liquid oil. What is in the liquid oil? We have a mixture of TGs, triglycerides. Each triglyceride has its own melting point. So now we cool down from some high temperature, elevated temperature, we cool down. When the temperature reach the melting point of that triglyceride will start to crystallize. Because we reduce the temperature to the temperature below the melting point of the triglyceride, so that the triglyceride can crystallize. That is the principle of fractionation. Very simple. But why we want to do fractionation? Among other things, the objective is to remove minor components detrimental to the application of oil. For example, the dewaxing of sunflower oil. Some oil, like sunflower oil, they have this component called waxes. Waxes are lipid. Remember? Lipid is a broad group of compound. We have waxes, we have true fat, which is triglycerides. We have waxes, we have phospholipids, we have what else? So many things. So this is everything called lipid. The fat, the true fat, which is triglyceride or triacylglycerol, is only one type of lipid. So that's a difference. Yeah? When you say fat, when you say lipid, fat, what's the difference? Lipid is a bigger group. Fat is a subset. It's one component within the lipid. So waxes are also lipid. And in some oil, when we extract the oil, the waxes also will be sometimes extracted together in the oil. Waxes is a big molecule. They have a higher melting point than the fat. So if waxes are present in the fat or in the oil, in the liquid oil, so in a cold country, especially during winter, the waxes can start to crystallize. It will crystallize first compared to the lower melting point TGs. So when they crystallize, they will form like apa dipanggil tu? Apa tu? Macam apa tu? Panggil cloudy, you know? Huh? Sorry? Opaque, yeah. Yeah, it's like a cloudy kind of thing suspended in the oil. Actually, nothing wrong with that. Perfectly safe to use. But if you go to the supermarket and you want to buy the oil, liquid oil, you see one clear oil, another oil with, what is this? Yeah. So the consumer would think that it's a bad oil, a poor quality oil, they won't buy. But actually nothing more than crystallized waxes. So we want to remove that. How do we remove that? By fractionation. Reduce the temperature, the waxes would crystallize, then we remove that by filtration or centrifugation. Okay, so that's one of the objectives of fractionation. Another objective, which is the main can see there are many fractions. Well, the objective again, before we look at the process, the enrichment of desirable triglycerides, for example, POP in palm oil. POP is a specific type of triglycerides containing the P stand for the palmitic, O stand for oleic. So palmitic, oleic, palmitic. Yeah. So this is a specific fraction. Why we want to have this POP? So we can use this fraction maybe, you know, in for to as the equivalent to replace some of the cocoa butter in the chocolate. Okay. So in the palm oil, of course, not only POP, we have many other types of triglycerides. But what if we want to just enrich that oil with this type of fat? So we can do the fractionation, we can crystallize other fat, other fractions, we end up with this fraction. So that's the meaning of enrichment of desirable triglyceride. Oh, I thought, okay. What question? POP pop, not K-pop. Saya pun tahu juga K-pop. Tahulah baca paper, tapi tak sempat nak tengok lagi lah. Later we look some of the application. We can also use fractionation as also another alternative to hydrogenation to get the trans fat, to get the trans-free fat. Yeah, because unlike hydrogenation, which always produce the partial hydrogenation always produce the trans fat, but fractionation just basically a physical process. We let each triglyceride to crystallize. That's all, by reducing the temperature, by cooling the oil. So to get fractionation of palm oil to yield fractions that can replace hydrogenated soybean oil in margarine, yeah, or other type of oil. So what is fractionation? So as I have explained just now, oil contain mixtures of TGs, different melting point, different solubility. If cooled carefully, so we start at high temperature, then we cool down. The more saturated, higher melting triglyceride will solidify first and can be separated. If you see the earlier part, which I don't cover, I don't have time to cover in the class, when you look at the chemistry and the physical properties of fat, what are the factors which affect the melting point? The presence of double bond. So you have more double bond, the melting point would be more double bond, the melting point will be they're confident, lower. Yeah, lower lah. If we have more conjugated bond, oh, okay. So, yeah. So by understanding what affect the melting point, so we can control the process so that we can get a different fraction with different composition of the saturated and unsaturated fatty acid. Okay, we stop here. I'll see you on Thursday. Okay.